All right. Hello, everyone. Thanks for joining us. My name is Roy Hassan. I'm the Business Development Manager for Amazon Athena with AWS. I'm joined with Shane Andrade. He's a Principal Engineer from SendGrid. All right. So today, a few things we wanted to cover. The first thing I want to talk about is kind of walk you through a few common customer use cases or trends that we're seeing with all of our customers using Amazon Athena. The next thing is I want to talk about something new that we're announcing at re:Invent today. We call this workload isolation and cost controls. So this is something that a lot of our customers have been asking for, and it's here, so we'll talk about that. And then lastly, I'll pass it on to Shane, and he'll talk to you about how SendGrid uses Amazon Athena to sort of reinvent and rethink a popular feature, email activity. Okay. So Amazon Athena was first introduced around this time in 2016. Since then, we saw a lot of customers, yourself in the room here, using Athena in a number of different ways, really exciting use cases, really interesting use cases. We see Amazon Athena being used to dive into service logs, whether it's AWS service logs, your own server infrastructure logs, and analyzing that data and really understanding what's going on. We see customers are looking at intrusion detection, right? Can we understand who is accessing our infrastructure and how they're accessing the infrastructure, and can we block them, right? We're seeing customers using Amazon Athena to take off ad hoc usage or ad hoc queries from existing data warehouses, kind of reducing the overall pressure on these mission-critical systems and moving them to Athena. Also looking at using Athena with the APIs that we have to build some new and exciting applications and services. And Shane will walk us through an example of what SendGrid did with the APIs. So customer trends. So before we get started, what I want to do is kind of walk backwards from the problem, and let's identify sort of who are our target audiences, or who's the target user. So there's two users here that you see on the screen. The first one is the data consumer. The data consumer is really interested with being able to discover available data sets and be able to easily query the data without really having to worry about too much. Do I need to move the data? How do I access the data? But also being able to bring their own tool and say, I'm very familiar with SQL Workbench or some other tools, and I want to use those tools to query my data. The second user that we have here is the data engineer. Right? The data engineer is concerned with properly securing, protecting, and delivering this data in a maintainable and scalable way. Right? So we still need these data engineers to help us bring the data from its raw form through some kind of data pipeline, process it, secure it, encrypt it, and then make it available to the data consumer in a way that's easily consumable for them. So the first use case or the first trend that we see with our customers is data lakes. And what data lakes are in one sentence, and there's a lot of permutations to this, and you'll see much of this throughout re:Invent. But basically, it's taking all of your data and being able to store it in a common single repository inside of the cloud in AWS. So then you can take that data and you can use it in a number of different ways. Another concept or another idea in a data lake is having the separation of storage, metadata, and compute. So you can pick the best tool for the job for each layer of the architecture and be able to scale it independently. Let the animation play. Great. So to build a data lake, the first thing the data engineer really needs to do is they need to understand the source systems, right? Understanding where the data is coming from, what format it's in, what do I need to get out of that data? And there's a number of different things. And you see on the left side, mostly streaming type of applications, but on the bottom, EDW, Enterprise Data Warehouse. That's more structured data, maybe bigger, larger type of operational data. But one example of taking that data in is using Amazon Kinesis Data Firehose. So this particular example is about streaming data. How can we stream the data into our data lake and be able to process very easily? And I'll show you in a minute another way to do this, but there's a number of different ways to get data into your data lake. So one of the things that Amazon Kinesis Data Firehose announced was having the ability to take that raw data and actually convert it, right? Take it from its raw JSON form or CSV form and convert it to a query-optimized file format. And when we say query-optimized, it means something like Apache Parquet or C that are columnar file formats that are better, more efficient for querying with Athena. The other thing it also does is it structures the data on S3 in a folder structure that's easy to manage and also help us improve performance and cost when we create our data. All right, so ingesting streaming data is one common example, and you'll see this with a lot of our customers. But another requirement that we see is being able to extract operational and also business data from existing databases and data warehouse. And this could be from Redshift, it can be from any other kind of data warehouse, from Aurora, from DynamoDB, right? How do we get that data out of those systems, bring it into our data lake, right, and start doing analytics and machine learning on top of that? So this process can be done in a number of different ways, but the common ones are a one-way copy, and also incrementally using something called change data capture, right, CDC. AWS Database Migration Service is a service that allows you to do just that, to take data from one source system and move it over to another source system. One neat feature of Database Migration Service is it actually lets you save that data not into a target database, but into S3 in a CSV file format. The other neat thing, last week, we announced a new feature for DMS that lets you write the data events, right? As you get these events in real time from your source database, write those events to Kinesis data streams. So now we're turning this process into a streaming process and be able to push it through the pipeline I showed you earlier, where we take the streaming events, send them to Kinesis Data Firehose, and then write them out into S3 in columnar optimized file formats and proper partitioning. So it's another way of tying this into our data lake ingestion process. All right, next, our data engineer really has a couple decisions to make. So a typical data processing pipeline, there are common tasks that need to be done. Things like deduplication, removing nulls, reformatting date and time fields. Those are all part of data processing jobs that anybody has to do. These tasks can easily be automated using AWS Glue ETL and configured to be able to process the data on regular intervals. Right, as data flows in from Kinesis or from other sources, we want to be able to sort of say, let's deduplicate, right? Let's clean this up. Let's reformat and restructure some of the data, and we can automate it using AWS Glue ETL. So what we're doing here is we're really removing the need for the end consumer, the data consumer, to do these kind of mundane tasks that are typical for their workload, right? They need to deduplicate. They need to restructure things. We can do that ahead of time. So when they get the data, they can actually do their job and not worry about it. Other times, there's some unique data transformations that need to be performed. They could be more complex. They could be more specific. Maybe you got some specific custom functions that you need to run on the data and process the data. Maybe there's some machine learning model retraining that you need to do. The data engineer then has the option of spinning Amazon EMR managed clusters to be able to take advantage of the power and the flexibility and the tools available to process the data in that unique way and then bring it back into the pipeline. So the next piece that we have to go through is once all the data is processed and stored in S3, we have the option now to store the data encrypted in S3, and we can use S3 standard encryption, or we can let AWS KMS manage the keys for us so that you have that flexibility. The other thing that our data engineer now needs to do is they'll need to configure AWS Glue crawlers. And these crawlers, what they do is they actually look at the data that you stored in S3, they understand the schema and the technical metadata of that, and then they create the appropriate tables inside of the Glue data catalog to represent those tables. So later, when we're querying it, we can simply reference those tables and be able to understand which columns and where does the data reside. After the data has been cataloged and we have our tables, the next thing we want to do is we want to configure permissions, right? typically in a normal work environment, maybe you want to open some of the data to your users, but as you're creating data lakes, you want to be able to protect it. You want to be able to restrict which user has access to which data, whether it has personal identifying information. We want to restrict that even more and make sure the right users have access to the right tables. So something new in 2018, in October, AWS Glue Data Catalog released this feature that we call fine-grained access control. And what this does, it allows you to attach policies to an IAM identity, such as a user, a group, or a role, as well as AWS Glue Data Catalog resources like databases and tables. And you can see in this example that we're creating a read-only policy to all the tables in the example_DB database. So this is a feature that you can go ahead and use today and be able to restrict users to access the data using these policies. Okay. All right, not clicking. Okay, here we go. So the next part, once we sort of did that, once we ingested all the data, we prepared everything for querying, now our data engineer, let's see if this works again. Oh, it's weird. All right. Now our data engineer exposes Amazon Athena to the data consumer, right? So once we created our data lake, now we give the data consumer an interface, right? A way to query the data inside of our data lake. What the data engineer also needs to do is they need to grant that data consumer access to the Athena service. So they have to define the right policies that will give the user ability to execute queries on top of the Athena service. They also have to define permissions for databases and tables, like we saw in the previous slide, that tells them which users, which tables they can access and which one they cannot. And then lastly, also give them access to the S3 buckets where the physical data actually resides. So user can then execute these queries using the Athena console. So if you log in, we have a SQL interface. You can go in and type your queries. You can use BI tools. Amazon QuickSight is a great choice for that. There's a lot of other BI tools that you can use as well. You can use the AWS CLI. So if you're using CLI tools for automation or you're building kind of scripts, you can use that as well. The SDK as well. So you'll see from in Shane's talk how they're using the SDK, the APIs, to be able to run queries on Athena. And then also the JDBC and ODBC drivers. They're available for you today to be able to connect popular BI tools. And I'll talk about that in a minute as well. Just to kind of show you how it's common to execute ad hoc queries, and we see that a lot, but also using the CLIs and the APIs to build automation, right? To build processes to automate your queries, run them in the background. Less interactive, but it fits better into a data processing pipeline. So this is just another example where on the big box we have sort of the data lake, so what we've defined so far. And on the right side, we can bring these different tools, we can bring different processes to do different things. So reporting and analytics can bring, using JDBC and ODBC drivers, any number of BI tools. Machine learning, you'll see in a minute when I talk about Amazon SageMaker and how can we integrate Amazon SageMaker for machine learning and model preparation and exploration. How can we integrate that into our data lake? Also custom applications, right? How can I build custom applications to integrate into my data lake and use that critical data to start making some data-driven decisions and build applications that are driven based on my data. Here's an example of just a few partners that support the Amazon Athena, JDBC, and ODBC drivers. This is just a subset of them. There's a whole lot of other ones that you can use. Definitely feel free to go out there and use it. Don't think that if your preferred BI vendor is on the list, it's not supported. Go onto our website. We have a longer list, and then the folks integrate with our drivers. All right, so we talked about consuming the data. So one user or one consumer of the data is a data analyst, right? So when we look at this, there's a number of things that we did over this 2018, some improvements and optimizations that we've done to really help this data analyst be more efficient and be able to get access to the data much quicker. So the first thing we did was we released a newer version of our JDBC and ODBC drivers with 2 to 5x improvement in performance. So these are some improvements that we've done to the driver itself. So it gives your users that are using the JDBC drivers or the ODBC drivers with BI tools, it gives them much better experience, much more snappier, and something that they're more used to. Create table as select. So this is a feature that we also introduced. It's a really neat feature. It basically it creates a brand new table from the results of another query. So if you run a query and you want to take that result and you want to save it as a table, and then reuse that table for future queries or let your other users query that table, create table as select lets you do that. The other thing that create table as select allows you to do is actually reformat the data. So if you're starting with a table that's based on text formats like CSV or JSON, you can create a new table from the result set, but actually save it in Parquet or ORC file formats, columnar optimized file formats, and the next time the users query that data, it's optimal, much faster, much more cost effective. There you go, it's working. The last one is Athena views. So this really allows the analyst to really abstract some of the complex queries and transformations that they do inside their SQL, and also really expose the columns and the rows that the end user is interested in. So you can come up with a complex query that has a lot of business logic or other transformations, and then save it as a view, and then let the user that is consuming it only see that view. So they're not really bothered by the complexity of the actual query. So these are really good enhancements and great features that we released over the year. We see a lot of great feedback from customers around how this improved their workflow, helped them be more efficient, and really get access to the data quicker. So here's another new feature. This is something that we recently announced over I believe, last week. So this is a change to, or an enhancement to the JDBC and ODBC drivers. And it gives you the ability to federate access using Active Directory. So previously, you'd have to use your AWS access key and secret key to be able to authenticate the JDBC driver and use the service. Now what you can do is you can actually connect the driver to Microsoft Active Directory, so your users are logging in with their Active Directory credentials and are not bothered with managing access key, secret key. This is a really good feature also for the data engineer, because now they don't have to manage AWS access keys and distribute it to their users and deal with refreshing them and then potential leaks and things like that. So this makes it very, very easy to integrate with new users coming on board, give them access, let them get started quickly. All right, automated reporting. So a common use case that we see for Athena is automating the execution of queries to generate operational and business reports. So here's a reference architecture. This kind of helps you get started. It's not the full thing. There's obviously changes that we can make to this to improve it, but this is just a way to get started. So the first thing we do is we want to schedule or create a scheduled Lambda function that calls the Athena APIs and kickstarts queries, right? This could be one query. This could be a whole bunch of different queries. It's really up to you how you want to set this up, but you can run your query. The next thing we want to do is we want to actually take the query ID that we got back from those queries, and we just want to save them in Amazon DynamoDB. And the reason we do that is if later we want to go back and look at those, at the status of those queries, or we want to see if a query failed. Why did it fail? I need to know the query ID so I can go look them up. So we store them in DynamoDB. You can go back and look at them later. Once the query completes, or the query is complete, the result sets are actually written automatically for you into Amazon S3. The next thing that happens once the data gets stored in S3 is you can actually set an S3 trigger on that particular bucket that triggers a Lambda function every time a new file is saved into that bucket. So what that does is it lets us actually take that notification and sort of say, okay, the job is now complete. I'm going to notify maybe an SNS topic and say, the job complete, let me send an email notification to a system. Maybe I'll send it to PagerDuty. Maybe I'll send it some other notification into an orchestration system that now tracks the progress of these reports. But this is a very simple kind of reference architecture, a serverless solution that lets you run automated queries, automated reports very easily. All right. So I said I'll come back to the data science use case, and here is just one example. So you can see again, on the left side, we have our data lake. This is sort of represents our data lake. But what we want to do is we want to enable the data scientists the ability to access the data very easily. Of course, they can go to S3 directly and pull the data in and play around with it and do what they need to do with it. But it's easier and actually more secure if we give them access through Athena to be able to query that data that they want. Because what happens then is we already pre-processed the data. We removed all the duplicates and reformatted things. We applied security and permissioning to that data. So now all of that is already contained in our data lake. If we give our data scientist user access via Athena to the data lake, now we're controlling the whole flow. PyAthena is a really neat Python open source library that you can go and download and use. And basically what that gives you is a database type driver in a Python environment that gives you access to Athena. So it makes the workflow for that data scientist working inside a Python notebook very, very easy and just get started right away without really having to learn any new tools or any new patterns of access. So applications, so custom applications. So you'll hear from Shane in a few minutes sort of what they did. But this is a really, in my opinion, a really, really neat feature of Athena. It really gives you the ability to use the APIs to build new applications on top of the data. So running SQL queries on top of data, almost like a database, but the data resides in S3. So the storage cost remain very minimal. The access pattern is very flexible, and you have the ability to sort of control who accesses the data and how. You can see in this case, AWS AppSync. If you're not familiar with this, they have a GraphQL backend easily integrated into Athena. So then you can build applications, whether they're mobile applications or web-based applications that maintain data for online access, but also for offline access. It has the ability to cache some of that data, which is really, really cool. Like I said before, AWS tools and SDKs, the CLI, a really great way to use the service. Again, you're not managing databases, you're not spinning up databases. So if you do need access to that data and you don't want to deal with database connections like JDBC and ODBC, you can do it via the APIs and the CLI. All right, so up till now, the common use case was a data lake. The next use case or trend I'm going to look at is inspecting AWS service logs. So many of the, here we go. Okay, so many of the AWS services already store all of the log data into S3. So services like CloudTrail, CloudFront, Classic and application load balancers, they all store that data inside of S3 normally in text formats like CSV and JSON. And the reason they do that is to really make those logs really portable and accessible to any modern tool, including Athena. So one key aspect of improving query performance and reducing the cost per user is managing the amount of data scanned. So you heard me talk about columnar file formats and partitioning. At the end of the day, when we talk about Athena, the one point about performance and cost is data scanned. So if we can reduce the amount of data that we scan, we speed up the queries, and we also reduce the amount of money that you pay at the end of the day. So that's something that we want to also take into consideration here. So as you can see here, we're using AWS Glue again. The idea here is to take the data in, convert it to columnar file formats, optimize the data, clean it, and then push it back into S3, back into S3 in partitioned file format. So previously you've seen Kinesis Data Firehose doing that in real time in a streaming way. In this case, we're actually taking bulk sets of logs, and we're running them through AWS Glue ETL, processing them, doing kind of the same thing, converting them to Parquet, formatting the output S3 location, and then writing the data back out into that. So when ingesting and storing log data, many times it results in a lot of small files. Some of you already use Athena today, probably noticed this, where you have a lot of kilobyte worth files, not megabytes, not gigabytes, a lot of very small files. So this is not really ideal when trying to query data. It's definitely recommended to sort of periodically merge these files into large ones, so they're much more efficient for querying. However, we're all working on an enhancement that would really improve query performance when accessing tables that contain a lot of little small files. So we understand this is a problem that customers have. There are some best practices that you can follow today to kind of get around it, and we recommend you keep following them. But we're also working to try to improve this behind the scenes, so there's less of that heavy lifting for you guys to do. All right, so at this point, data has been converted to columnar format. It's partitioned on S3, similar to our data lake use case. Now our data engineer is going to configure AWS Glue to be able to query, to catalog that data, and then we can move on. So we catalog it. Permissioning, of course, the same thing as before, and then we move on. So again, our data engineer now exposes Amazon Athena to the end user. The end user can start querying the data using the different tools that we have to offer. All right, so I'll go through this. So this is Athena Workgroups. This is a new feature that we are announcing today in beta. So Athena Workgroups, and you can see here, and I'll kind of read it to you again because I think it's a good description. So Athena Workgroups are used to isolate queries between different teams, workloads, or applications, and set limits on the amount of data each query and the entire workgroup can process. So think about this. It gives you workload isolation, be able to separate different type of workloads, ad hoc, reporting, automation. It gives you query metrics. So now you can actually get the metrics, the information about how long a query ran, how much data scanned, whether the query succeeded or not, available for you in CloudWatch. And also give you the ability to set cost controls to say, if a query exceeds a particular threshold of amount of data scanned, I'm going to cancel that query, right? Or I'm going to send some kind of notification to let somebody know that, hey, something is going on here. So creating work groups, this is just a screenshot of what that looks like. So the data engineers will have to go and define a work group. So whether they're defining work groups for different business units, different teams inside of the organization, they can actually define the output location of the work group. So if I have an ad hoc team, and I have a DevOps team, and I have an engineering team, they're all querying and doing different things, I want the output of their queries to be located in an S3 bucket that's owned and dedicated to them. So I have an ability through work groups to define that. The other one, I can also set KMS keys. So if I have different users of work groups, each one of them has different KMS key requirements, we can define it independently here per work group. We can publish all of those metrics into CloudWatch, like I said before, and I'll show you a screenshot of that. And then the last one is the data engineer now has the ability to sort of override all user configuration with the work group, which what that means is that when new users are onboarded to your data lake to query using Athena, they can be put into work groups. And by putting this checkbox, basically they don't have to configure anything on their end, right? They bring a BI tool, they use the CLI, they use the API, they log in, and that's it. All the configuration that we typically give you with the APIs and the JDBC now are automatically applied by the work group. So it makes bringing new users on board very easy and very seamless. So here is just a metrics report that you get from the work groups screen. It gives you total byte scans for the work group, successful queries, failed queries, query executions per, and then all this metrics actually goes into CloudWatch. So you get a per query metric, you get a per work group metric, so it's an aggregation of all the queries inside the work group. And then all of that goes into CloudWatch. So if you have more advanced use cases around alarming and reporting, you can do it in CloudWatch. All right, so when we speak about customers about having the ability to really control cost, right, for their Athena usage, we commonly hear two main scenarios. So the first one is having users who can execute whether they're bad queries or queries that just scan a lot more data than really expected, being able to stop them. Right? Not just let them run and rack up cost, but give you the ability to stop them. So we can, in workgroups, we can actually define that and say a per query limit. If the query exceeds a certain amount of data scanned, we can cancel that query right away. The other use case that we're seeing is giving users sort of building automations and more automated processes rather than ad hoc. And how do you separate the two together, right? How do you say, the ad hoc users are running X amount of queries, this is what their usage looks like, and the reporting systems are doing something different, and this is what their experience looks like. One of the common challenges that we're seeing is that if you have automated scripts running queries, when the ad hoc users come in and look at their history, right, they're not able to see what they ran because the automated queries completely overwhelmed the query history. Right? So now they don't know where they were, what they're running. So by using this, we can separate into work groups. Now, the other thing we can do is within the work group, because we have different users, different tools running queries, we want to be able to set a tiered or hierarchical thresholds so we can actually notify the data engineer, management, as usage starts to increase. So in this case, you can see here, we're setting a limit of 10 gigabytes for the work group per hour. So every hour, we look at the usage and we say, are we hitting that threshold, right? And if we're past that threshold per hour, we will send a CloudWatch notification, and then an email can go out, the email can go out to management or whoever to take a look at it. The other, we can then set another threshold that said at a 24-hour level, if the work group exceeded a terabyte of data, at this point, every query that runs, we're just going to cancel them, right? We're going to basically disable the work group altogether, and we're not going to let any more queries execute. And the idea here is that something went wrong, or either the users exceeded the amount of data scanned that you really wanted to allow. We're just going to cancel. We're just going to disable the work group and basically stop all the queries, and then you can go back and say, okay, is this a problem with the automation? Do I need to up the limit? What do I need to do? But at least you're protecting yourself from incurring a lot of cost without having any control over it. All right. And then lastly, and I said this before, all the different metrics go back into CloudWatch. It's not just the cost control type of metrics, the usage. It's also query succeeded, query failed, which is really helpful if you're trying to understand what is the overall experience of a work group. Okay, and then the last one with regards to work groups is around usage notifications. So as I said before, all these metrics go into CloudWatch. So you can actually go into CloudWatch and start build some more complex or more intricate sort of notifications and reporting on top of that data without typically just relying on the graphs that we provide to you in the Athena console. You have a lot more flexibility in here. And as CloudWatch adds more features and functionality, you can start taking advantage of them. All right. I'm going to hand it over to Shane now.
All right.
Yours hopefully works.
Thank you. Thanks, Roy. All right. So my name is Shane Andrade, and I work at SendGrid. I'm a principal engineer there, and I've been there about 5.5 years. If you haven't heard of SendGrid, this is not working for me. SendGrid is an email SaaS company, and we send about 45 billion emails a month from our 78,000 customers that reside in over 100 countries around the world, and we ourselves, we're distributed amongst 4 offices, mainly located in the US and 1 in London. These are some of the top web brands that trust us to send their emails for them. You can see some pretty popular brands like Uber, eBay, and they trust us to send their email for them. So this is our product line. We started in the transactional email space, and if you're not familiar with what a transactional email is, it's basically an email that was triggered off of some user action. So like maybe an order confirmation or a password reset. And these are just kind of one-off emails that are based off of some one-time user action. Once we tackled that, we jumped into the email marketing space with our marketing campaigns application. And this is where email marketers send their promotional emails, newsletters, offers, and such that they send in mass to their recipients. We also have something called the Parse API, which is A little bit different, it receives an inbound email on your behalf, and we parse it for you and send that to your HTTP server so you can automate against that. So you can handle things like support ticket updates, which is a really common use case we see for this feature. And lastly, which is what I'm going to be talking about today, is our email activity. Email activity is a diagnosis tool for our customers to be able to help self-service their issues with SendGrid. So maybe they're having some sort of deliverability issue, or they're not really sure if a particular email made it to a particular recipient. They can log into SendGrid, go to email activity, and they can view all of the events associated with that email message as it went through SendGrid. So a little bit more about email activity. We built it originally on-prem in the early days of SendGrid, and this is a high level of what it looks like. So an email is sent through our mail pipeline from one of our customers, and it's sent to us. It goes through our system. And as it goes through our mail pipeline, the pipeline generates various events as it makes its way through. Those events get collected and stored into Elasticsearch. Hopefully that email gets delivered on the right end there and to an email provider like maybe Gmail or Yahoo. And if a recipient chooses to engage with that email, meaning they open it or maybe click on a link in that email, then we collect those events as well and store them into Elasticsearch. So for any given message that we receive from our customers and send for them, we can see the full history of what happened to that email as it made its way through SendGrid and into the user's inbox. And it really gives a holistic view of what the journey of that email was. This architecture had some limitations, though. One of the limitations was that we could only store 7 days of history for a given user. And the reason for this is, there's a couple of reasons, but the main reason is this was a free offering as part of your SendGrid package, and our Elasticsearch cluster was already pretty large, and we didn't really want to invest any more hardware into it, as it would really eat into our bottom line because this was a free service. And so we kind of just capped it at 7 days, and despite the fact that we had a lot of customers requesting more storage. Furthermore, we had some high-volume customers. High-volume customers are customers that send more than maybe 100 million emails a month, and they were actually limited to just 2 days because of the amount of data that they were generating. And some of the technical limitations on the Elasticsearch side prevented us from paging deeply into their data set, and we could only really give them 2 days of their history. So this was another limitation that we had on our previous system. And lastly, as we went from that transactional space, which is really focused on developers as our customer, we started going into that marketing space where we had a lot of non-technical users start to join SendGrid. We had email marketers, small business owners, and they didn't really understand how to use this existing system of dealing with events rather than something like emails, which is what they're familiar with. And they didn't really know how to translate the concept of an event to a particular email, and that was really burdensome for them. So it was at this point we decided, okay, we are going to re-architect this, but we need to think of a better way to do this. We had a few issues of how we were going to get started, and one of those issues was around how we were going to handle provisioning. We knew that because some users wanted to have a longer search history, we could charge for this. And the users that wanted more history, we could provide maybe a 30-day history for them. And we had people who maybe didn't want that, and we could offer them maybe 2 or 3 days of history. And so we weren't really sure what the demand was going to be. And so we had some risks around how we were going to provision our hardware. Again, this was all on-prem at the time, and so we weren't really sure if the demand was going to be really high or really low. So if we under-provisioned, meaning that we had more users than our hardware could support, that would affect other people on the cluster. Query times would be slow. We would probably have delays in ingesting data. So that was a risk for us. And on the flip side, of course, if we over-provisioned, well, then we're footing the bill for all this hardware that's not being used and it's just sitting there idle. So that was a risk for us as well. So we knew that we wanted to build this in the cloud. And this was about 2 years ago when we started on this project, and we built a prototype in AWS on Cloud Search. And it worked, and it did everything we needed it to do. And as Roy said, about 2 years ago, that's when Athena dropped. So right after we finished this prototype, we started hearing things about Athena. And we're like, oh, that actually sounds really interesting. And our solution architect even sent us over a sample architecture of what it could look like using Athena. And it really started to intrigue us. And that's how we got to Athena. So we replaced that with Athena. All right, so some of the things that actually drove us to use Athena. One is that it was serverless. This was a huge plus for us. This was our first step into the cloud as a company. We really had no prior cloud experience, and so this really took one big risk away from us moving onto a completely new platform. We didn't have to worry about managing servers or provisioning anything, and it made it really easy for us to get started. Second was its elasticity. The elasticity of Athena and S3 were perfect for our pricing model that we wanted to have, where we had this free tier and we had this paid tier. We didn't know what the demand was going to be, and Athena charges basically per use, and that really fit our costing model very well. And lastly was the API integration. It was very flexible. We could integrate in a number of different ways. We could use the AWS SDKs, we could use the CLI, we could use JDBC. I don't think they had ODBC at the time, but because we were running this on Go, we couldn't obviously do JDBC integrations. So the API integration was really simple for us to get started. All right, so this was our first architecture during our beta. And the way it worked was, at this point, we had all the events that were getting emitted from the mail pipeline going to Kafka. That's the little thing at the top. And from there, we had a consumer off of Kafka called Secure. Secure is an open source project from Pinterest that we just used with a few modifications out of the box. And basically, its job, what it does is it consumes off of a Kafka stream, and it writes up to S3 in the format that Athena wants. So it pretty much did all the heavy lifting for us, and it helped us get to market faster. So basically, its job, it consumes off of Kafka and writes up to S3 every couple minutes. Once it makes it into S3, we have partitions set up per user. I've seen a lot of, a really common partitioning scheme is by date. We chose user ID because all of our queries coming in were going to be based on a single user. There's never any sort of cross-user queries going on. And of course, as a SendGrid user, someone shouldn't have access to your data, and you shouldn't have access to somebody else's data, so this made sense for us. And so that's the ingest portion. And then on the right side, we have our API, which exposes all the APIs that we offer to our customers. And it takes the incoming request from our customer and then basically translates that incoming query into a query that Athena wants, and then sends that to S3, and then sends the results back up through the API. So a little bit more in depth on that. On the left, we have the user, and they'll send in something that looks like this. So they'll say, show me all the emails that were sent to johndoe@gmail.com, and the status is delivered. So the API takes that, it parses it, creates a parse tree, translates it into the SQL format that Athena wants, sends it something that looks like this. Athena, of course, returns a CSV result. And since all of our APIs deal with JSON, we take that CSV result and convert it back into JSON and return that back to the user. So that's kind of a high level of what the API does. So this architecture worked pretty well. But as we got deeper and deeper into the beta, as time went on, we noticed that our queries were beginning to slow down. And we were kind of wondering, what's going on? We started scratching our heads over this. We noticed that the only thing that really changed was the number of files. And as Roy kind of mentioned, this is, if you've worked with Athena, this might have been an issue for you as well. We noticed that the number of files correlates to the query times. So we ran a little experiment just to test our hypothesis, and this is what we saw. So we took 1 million records and put them all in a single org file, uploaded it to S3, had Athena query it, and results came back pretty quickly. We then took those 1 million records, split them across 10 files, uploaded them to S3, queried it again, took a little longer, did the same with 100 files, 1,000 files, and then 10,000 files. We saw every time we increased the number of files, even though it was the same data set, it was just split across different files, we saw the query times increase. And so we knew that was going to be an issue for us. So at this point, we knew that we needed to handle the older data differently. So this is our second architecture. And what we ended up doing was we ended up making, basically forking the Kafka streams. And So on the very left side, we have Secor still. Secor is still pulling off of Kafka, and it's writing up to S3 into what we're calling the batch layer or the batch bucket now, and it's still partitioned by user ID. The only difference here is Secor, instead of writing out once every couple minutes, it's now writing out once an hour. So over the course of an hour, it's just consuming off of Kafka, and then once an hour, it uploads to S3. Then in the middle, we introduced this concept of a speed layer, which this Secor, it's pulling off of Kafka, and it's writing up more frequently, once a minute. And it makes it into the speed layer in S3. We changed the partitioning scheme here on this bucket. We did a mod 100 of the user ID instead of individual user IDs. The reason for that being that basically we got some of the org benefits out of that. We were able to group data together more, and we didn't have just one event per file, which is pretty much pointless for org. So we ended up batching those together and getting a little more use out of that. So basically, over the course of an hour, what happens is the speed layer Secor is writing out a bunch of files, or a file per minute per partition. And then on the left side, at the end of that hour, the batch layer Secor uploads its file, and then the data in the speed bucket gets deleted. And so that's how we kept the number of files down. The way we handled that on the Athena side was we basically set up each of those as a separate table in Athena. And when we issue a query to Athena, we issue a single query and just union distinct the results together. And that deduplicates any of the data and also queries both places and also just returns a single result set. So it kept our API more or less the same. So that worked great until one day it didn't. What we noticed was as we got very close to the end of our beta, we started ramping up the number of users. And as we added more users, we were seeing memory issues on the batch layer Secor. The reason being is that over the course of an hour, it had to store more and more data in memory before it could upload to S3. And so we were getting memory pressure, and it would eventually, the process would eventually die, and we had to find another way around this. So this was our third and final architecture. We realized that we didn't want to handle the speed and batch layers separately from the on-prem side. We needed to do that within AWS. And this was our solution for that. So again, we start with Secor consuming off of Kafka, and it still writes up to the speed layer once a minute. We enabled S3 event notifications on this bucket. So kind of as Roy mentioned, you can get triggers based off of when file changes occur to S3. So whenever we upload a file or delete a file, those events get sent to SNS. And then from there, they get forwarded to SQS. And then we have a Lambda consuming off of that queue on SQS. And those get written to Dynamo. So the reason why we do this is the following reason. This is what ends up being stored in Dynamo. So for a given partition, we know the number of bytes and the number of files that are in that partition on S3. And we use that information with another Lambda. So this Lambda wakes up every so often and says, hey, Dynamo, which partitions are too large? Which have too many files in them? It gets that response from Dynamo and then hands that off to Glue. Glue at that point takes those files that are partitioned by a mod 100 of the user ID, repartitions them by individual user ID, and then sends them over to the batch bucket on S3. On the batch bucket, we also have event notifications enabled, and they go through that same cycle of SNS and eventually make it into Dynamo. Now, the reason why we go through the whole trouble of putting stuff into Dynamo rather than just querying this stuff off of S3 directly is because S3 is actually really good at what it does in terms of storing and retrieving these objects, but it's not really good at querying the sort of like the metadata of the file system or the files themselves. So we have to kind of cache that separately, and that's what we use Dynamo for. And then as far as querying the data, it's exactly as the previous architecture. We still have Athena with two separate tables, one for the batch layer, one for the speed layer. And then it unions the results together and returns them up to the API. So this was our final architecture, and it's been in production for about 8 or 9 months now since we launched, and it's been working great. So some of the benefits we've seen from using Athena since we switched over from our on-prem solution, one is just the scalability. It has scaled tremendously. So as we add new users to the system, as we get new SendGrid customers, we haven't had to make any architectural changes. The system just scales, and It's built on a very proven technology, S3, and Athena has now, to us, proven itself as well in terms of scalability. So we're really excited, and we're actually using it in future projects as well. Another thing we've seen is the reduced sort of hidden costs that we see with a lot of on-prem solutions. We have, with our on-prem Elasticsearch cluster, we had a lot of DevOps support. We had to maintain the servers, update the hardware, update the OS, update Elasticsearch, manage the cluster, all these things that take up time from our precious DevOps resources. And we don't have that with Athena. We've had 0 DevOps tickets in regards to this project, so we're really excited about that as well. And lastly, the most importantly, is that our customer satisfaction has gone through the roof with this product. We've had tremendous feedback on customers using this, how much easier it is to use, and the increased storage history has been really great. So we're really thrilled about that as well. And just to close it out, I want to reiterate some of the things that I had mentioned that initially brought us to Athena, and just confirm that after using it, these are the things that drew us to it, and after working with it, these are actually true. So yes, it is serverless. We don't have to manage anything. We don't have to worry about provisioning VMs. We don't have to worry about scaling or even auto-scaling. It just magically scales behind the scenes for us. So that's been super, super helpful in terms of development time and just engineering time in general. Second was the elasticity. Our costs are very much accurate because we can base them off of what the expected usage is going to be, rather than guessing like, oh, we might have a 10% adoption of this for paid people versus free people. So this has been really great for us as well. And then lastly, the API integration. After using the AWS SDKs, the API integration was super easy to use, and they're all consistent across all of their products line as well. So that's whenever we integrate with another Amazon product, we can expect the same level of quality and just the consistency across them as well. That's been fantastic also. And that's all I have.
I think we're good.
Yeah.
All right. Yeah, thank you very much. Thanks.
So yeah, thanks everyone for coming. Please complete the session survey in the mobile app. And did you want to mention about the?
Yeah. So I think we have time for a couple questions, but we also have sort of like a meet and greet a little bit after this, just actually right after the session up in Willow Lounge, I think one level up. Yeah. So if some folks have more specific questions, you want to chat with us, please meet us there. But I think we have a couple minutes still. Right. Besides that, thank you very much. Appreciate it.
Thank you.